Alright, so now we're looking at lesson 12-1, tangent lines. This one is a pretty easy lesson. It says for theorem 12-1, if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. And you're probably thinking, what? What? Tangent? A line tangent? Wait, that doesn't make sense because tangent is opposite over adjacent, right? Okay, well, unfortunately, we have two different things that use the word tangent in geometry. We have our trig ratio tangent, which is opposite over adjacent, which we just finished with, but we also have tangent lines, okay? So this is something totally different, so don't think about opposite over adjacent right now. Tangent lines are when a line touches a circle in exactly one point. So see that point P right there? That is the one point where line AB is touching circle O. And it doesn't look like that because they would have to blow that circle up super big to make it look like it only touched in one point. Okay? So it's not practical to do that. So you just have to remember that it's actually touching in one line if it says tangent. In one point, I mean. Does that make sense? Okay. Theorem 12-2 says, if a line in a plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. Okay, these two theorems are actually converses of each other. The first one says, if the line is tangent to the circle, then it's perpendicular to the radius. Okay, so that would tell me that this is a right angle right here. Okay? The second one says, if the line is perpendicular to the radius, then it's tangent. Does that make sense? Okay. Theorem 12-3 says that the two segments tangent to a circle from a point outside the circle are congruent. Okay, so if you look at the picture, they're saying from point B to point A, that line is tangent to the circle, and from point B to point C, that line is tangent to the circle. Since they both come from point B, then they have to be congruent. Does that make sense? Okay. Look at our definitions. A tangent to a circle is a line, segment, or ray in the plane of the circle that intersects the circle in exactly one point. So you can see that's the important part of the word tangent, is that the line, segment, or ray is going to touch the circle in exactly one point. Okay? The next word, the point of tangency, is the point where a circle and a tangent intersect. So a tangent intersects a circle in exactly one point. That one point is called the point of tangency. Okay, so if you look at the picture, the top box is pointing to the line that touches the circle in one point. And so that is a tangent. The second box is pointing to the one point where the line touches the circle, so that is the point of tangency. Okay, so next we talk about a triangle that is inscribed in a circle. It's inscribed in the circle if all the vertices of the triangle lie on the circle. Now this is the only definition that they gave us that they didn't draw a picture for, so I kind of felt sorry for it. So we're going to draw our own picture, okay? So here's the circle, and if that circle had a triangle inside it where each vertex of the triangle touched the circle, then that triangle is inscribed in the circle. The triangle is inside the circle, so it's inscribed in the circle. Does that make sense? Mm-hmm. And then the next one, a triangle is circumscribed about a circle if each side of the triangle is tangent to the circle. Okay, so in other words, each side of the circle touches, each side of the triangle, I'll be okay, touches the circle in exactly one point. Okay, because it's tangent. All right, any questions? All right, now here's the confusing part. On your papers, I messed up. So example 1 is actually on page 3. See, there's front and back, front and back. So you're actually going to look at the first side of the next page. Sorry about that. Okay, so example 1. Is everybody there? Okay. Finding angle measures. BA is tangent to circle C at point A. Find the value of x. All right, so since they tell me that BA, which is this line right here, is tangent to the circle, doesn't that mean that this has to be a right angle? Okay, so I know that's 90 degrees, and then they tell me angle B is 22 degrees. So can't I find angle X because all three angles have to add up to 180? So that's what we're going to do. Because BA is tangent to circle C, angle A must be a right angle. Use the triangle angle sum theorem to find x. So the measure of A plus the measure of B plus the measure of C has to equal 180. I know angle A is 90. I know angle B is 22. Plus x would equal 180. 90 plus 22 is 112. So 112 plus x has to equal 180. And then I'm going to subtract the 112, right? So 180 minus 112 is 68 degrees. Easy peasy lemon squeezy. Okay, so go on to the second example. Now, sometimes students think these are really difficult. Guys, they are so easy. Darn it.